First of all, we will discuss what is Euler's method. Okay. So look at this diagram. So let us consider there's a point A on the curve, right? Look at this curve, point A, and its coordinate are x n minus 1 and y n minus 1, right? And let there is a one point B. This is the curve is called the solution curve, okay? And there's a point B is very close to the solution curve, and you can see its coordinates are xn and y1, and there is a relation between xn, xn equals to xn minus 1 plus h, even if you can see this from this figure. Okay, so xn will be equals to xn minus 1 plus h. Okay, so we will use the gradient method to find out the yn. Okay, so so gradient equals to, right? So we find out the gradient at point A. So what will be gradient at this point? We know gradient equals to the vertical, this one, vertical length yn minus 1. Okay, and here horizontal is xn minus 1. We know, and this is yn minus 1 over, we know this difference. What is the difference between this one? H. So you can write h here, right? But this is what a gradient at a point is always dy over dx. You can write dy over dx, or you can write right, and dy over dx, or you can write in terms of f, or you can write in terms of y dash. So this is the gradient, right? So you can do cross multiplication, h times dy over dx will be equals to yn minus 1, right? Or you can shift this yn minus 1 to other side, so this becomes positive, equals to yn, or you can write yn equals to yn minus 1 h dy over dx. So this is the Euler's formula, Euler's method to evaluate yn. Okay, so this method we will use to evaluate this yn, but you will have to use calculator. You must know how to use calculator. So we will discuss. First of all, we will make a question, and then we will put value in the question. Okay, so let's look at the exercise. Dy over dx equals to square root x over 4y. Okay, where y equals to 4? Okay, where y equals to 4 when x equals to 4. Okay, use Euler's method with step size. So step size means h. Step size always h. Okay, point 1 to find an approximate value of y when x equals to 4.5. Okay, so what we have to find out, how much y when x equals to 4.5. Okay, so let's we understand this through the calculator, your GDC. So we have formula yn equals to, right? Formula is yn equals to yn minus 1 plus h times dy over dx, right? So here what is the yn minus 1? It means beginning. It's the beginning term. Okay. So here you can see this is the 4, right? This is 4. Understanding? This is the means it's starting from the 4. Okay. Plus h is 0.1. H is 0.1 and dy over dx equals to, we have square root x over 4y, x over 4y. Okay, so this is the y. So but we cannot calculate this manually from here. From this point we will have to use calculator. Okay, we only writing the equation from here, and this is the equation. As you guys know, this equation we are getting from this data. Okay, so let's discuss how to use calculator. So yeah, guys, now you have this Casio calculator GDC, and for Euler's method, you will use this recursion. Okay, RECUR. This will be seen on your calculator when you click on the menu part, right? So I will execute it. So I have this one. I have this part, right? And this will be seen on your display. And but before filling up data over here, you need to set here. Okay. Set the table. So set will be here. You will press F5. Okay, so F5 here. Start always from 0, right? So you no need to write anything in the start portion. You have to write at the end portion. So according to this question, 5 is suitable because we have to find the value for 4.5. Okay, 4.5. And step size is 0.1. Step size is 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5. So I'm getting this in this 5 size. If you wish, you can increase, you can write more here, but that depends on the data, right? But I think 5 is enough here to get the value of y 4.5. Okay, so yeah, and now this is a0 and b0. A0 and b0 will be here 4. Why? Because this is starting from y4 when x equals to 4. So a0 and b0 will always be given in the question. Always will be given, right? So you will write here a04, b04, right? And then exit. So an. So if you guys remember, I have already shared yesterday one PDF where you have to all the Casio command are given over there, right? So an equals to this an plus 1 means you will have to write here the first term. You press F4. Okay, then you will see here n, an, b, and cn. So then F2 an and then plus an plus step size. Step size is here 0.1. Okay, step size. So 0.1. Okay, this is the step size. Okay, now bn means here the equation, and the equation was let me see what is the equation. So here you write bn means yn minus 1, right? And then there is a plus, then there is a plus, step size is 0.1, then there was a dy over dx, and dy over dx was square root x over 4y. I think, yes, x over 4y. I think it's better to use calculator. I mean, this is bracket. This is x divided by 4y, 4, then yes, y. Let me check. Oh, sorry. One mistake I have done here. X means an. Okay, x means an. Sorry. Divided by 4y means 4pn. Okay, because we have to write in terms of an and bn. Close the bracket. Right, close the bracket, and then just okay. Then see the table. There is table option. So you can see this table over here. You can see this. We need 4.5, right? So you can see this 4.5. Then y will be 4.25. When x is 4.5, y is 4.25. Understood this one? Do you need again? You can later I will share the recording. You can rewatch the video and then you can understand how to use calculator. But if you have any doubt, you can ask me. You can write 4, but simplification is not required. But if you wish, you can simplify as well, no problem. So or you can write simply yn equals to yn minus 1 uh, plus 0.1 and derivative is x over 4y, right? You can write this way also. So yn means this is bn plus 1, right? Yn means bn plus 1. Yn minus 1 means we are using pa, right? And for x we are using an, and for y we are using obviously this we will find out in the sense. One small correction I would like to do here. This we should write this one. Even if you do not write, it's understood, because in calculator we are using an for this part and bn for this part, right? What we are writing this one and an over 4 bn, right? So actually it's understood. Initial point will be xn minus 1 and y will be yn minus 1. So this way you can do this thing, Euler's method. How to use. Okay, so if you look at this one, it means this derivative is given, dy over dx is here 1 minus y. Okay, this value means this is the b0. Okay, b0 minus 1 and a0 equals to 0 in your calculator. This is useful for your calculator. There is a0 and b0. You will write this one, right? Step size is means h equals to 0.5 and find y. Okay, so how many terms you should write there? So there look, 0 first is 0, then 0.5. Okay, you add here, then you okay 1. Okay, this we have to find out, right? We have to find out 1.5. So n equals to 1 2 3 3. At 3 you can get, okay, because 1 2 3 0 is already there and we need this. So you can use calculator, right? So let's learn how to use calculator for this again. As you know, we use this recursion for Euler's method. So first of all we need to set. So and I think we need 3, so it's enough, right? 3 over here. Okay, a0 is a0 is 0 here, right? A0 is 0 here and b0 is -1. Okay, table, we have set the table, it's okay. Then exit, it's an plus step size. So this is an and plus step size is 0.0 and 5. This is the step size. Okay, here you have to write bn, right? This is bn plus okay, what is the this one? 1 minus. Okay, yes, wait a minute, we have to set the equation first, so that 0.05 and bracket 1 minus bn. So okay, table. So this is the table and as we can see, this the answer for this. 0.15, it will be negative 0.714. Using GDC. But guys, you have to, in exam, you must write the formula. Okay, don't forget to write the formula. Formula means this formula, this one, this one. So using GDC, we get yn equals to, it was negative 0.71. I think, let me see calculator once again. Yes. Okay. So yn means what here? N is what here? It's very important to show. It means we had to find out the value of y at 1.5. So it's better to write here over here y 1.5. Okay, 1.5. Sorry. Just a minute. It was 0.15. Yes, equals to this much. Okay, this is the value 0.15. So when x equals to 1.5, y will be negative 0.71. So guys, this question number 3. This is question number 3. You can see derivative we have dy over dx equals to 2x square plus 1 over x times e is raised to power y. Okay. So this is the equation. This is the equation for the Euler's method to find out yn. So yn equals to yn minus 1 plus 0. This is step size, right? This one. So you get a marks for this equation. It's very important, right? You will get mark for this writing for this equation, right? So in your calculator, if you see a0 will be 1 because x equals to 1 over here. Y b0 will be 0 because y is 0 here. Step size is this one, 0.025, right? And then for an plus 1 you write an plus step size, and for bn plus 1 you will write bn plus this step size and the derivative, right? So you will replace here like x replace x by an, okay, and y by bn, right? So what you will do here, the thing you have to put in your mind, replace x by an and y by bn. Okay, this is for your calculator. Sorry, an like this, bn like this, not a is to the power. Okay, it's like this. Okay, and then regarding how many steps you need, so you can see here. Okay, and at what point? So you x equals to, you can see 1 and you need to find out 1. So 4 steps are enough, right? Because first will be 1.025, 1 point, then 0.50, and then 1.075, and then you add here 1.100. So 1, 2, 3, 4. So ends at 4. So you write that 4. So please try calculator. Everything I have discussed on the board, and you know how to use calculator. You will get the answer for how much y when x equals to 1.1.